Hello everyone. Today we are going to look at rational exponents and what rational exponents really mean. We used to always have just nice numbers up there in our exponent, numbers like 2, numbers like 3, 4, or even a -2. We understand what that means. To remind yourself real quick, this means 1 over 4 to the positive second, so that would be 1 over 16. But what happens if I put fractions up there in my exponents? Well, fractions, let's first look when I have a 1 up here, so only focus on this number down there, the denominator. That will just be the nth root out of a. So in other words, the denominators are roots. Denominators mean roots. Let's do a few examples of this. Let's first try to rewrite from one expression to another. The first thing that we are trying to do is from the exponent to a radical. Let's try to take something with an exponent and rewrite it with a radical sign. So the 3x to the 4th raised to the 1/5, if I want to rewrite this will be the exact same thing. The denominator is 5. 5 down here is a 5. And that means that I will just simply get the 5th root out of 3x to the 4th. This is the exact same thing. Both expressions are equivalent. It's just a different way to write this. So we are just practicing this at the moment. So 100 raised to the 1/2 means nothing else but, well, the square root out of 100. We know that, strictly speaking, this 2 up here is not necessary to write. It can go away. We do not need to write this. You just need to understand that it is there. And where does it come from? It comes from this 2 right here. Let me throw that 2 away and let's put that 2 up there. And what is this? Well, in this case, I can simplify this. The square root of 100 is nothing else but 10. So, really quickly, what does 4 raised to the 1/2 mean? Well, 4 raised to the 1/2 is going to be the square root of 4, and that is equal to 2. Let's have another example here that we have written down. This is the -64 raised to the 1/3. What are we going to do? We are just going to look at the denominator down here. I have a 3, and that means I will get, if I rewrite this, the 3rd root, the cubic root, out of a -64. And the cubic root out of a -64, if I rewrite it like this, maybe that will help. Because in the future, this is what we are going to do. A -64 is the same thing as a -4 raised to the 3rd power. And we have seen in the last lecture that this will be just -4. All right. Now let's go in the other direction. Let's go and write something with a rational exponent that had a radical sign to begin with. So if I have here the 5th root out of 13x, and I want to rewrite this. I want to take this and I want to rewrite this with a rational exponent. Then all what I have to do, I take this radicand, the 13x, and I have to be careful that I will place parentheses around this. Now I'm going to raise this to the 1/5. Remember, the denominators are the radicals. Those are the roots. And that was already it. Doing the same thing with the next expression here. Well, what number is the index in this case? This was a 2 that we don't need to write if I just write the square root, but I need to understand it is there. So if I now rewrite this, I do the same thing as before. The radicand was x to the 5th, and I raise this to the 1/2. So the square root is nothing else but something raised to the 1/2. But here's the thing. In this particular case, I can do something else. I have one exponent and raise it to another exponent. So what did my rule say I'm supposed to do with these two exponents? We have seen this in some sections before. At that moment, you will have to multiply your exponents. And 5 times 1/2, that is nothing else but x raised to the 5/2. And these are the ones that we will be looking at more in the near future. So if I do this, the same thing with the next expression right here, I have x to the 6th, which was the radicand, and I raise this to the 1/3. Why do I raise it to the 1/3? Because this was the cubic root, and roots are numbers from the denominator. And now I see that I have one exponent raised to another exponent, so I will have to multiply these two exponents. And 6 times 1/3, that will be 6 divided by 3, is nothing else but x squared. So we are now starting to make it more complicated, slowly but steady. If I not just have 1 up here in my exponent, in my numerator, but some number, m, then this will be the same thing as the bottom stays the same. The bottom in your exponent is the root, but the top is the power. So in other words, you can think about it like this. I'm allowed to write this in 2 different ways. First take something and raise it to the m power and then take the nth root out of it, from inside to outside. Or first take the nth root and then raise it to the m power. If you go backwards, just do this. This outside here just goes underneath the m if you want to rewrite it. You see that? This n on the outside just goes underneath the m if you want to rewrite this. Again, the bottom is the root. The top is the power. I have not chosen wisely. Oh, I did. Sometimes I like to remind myself by drawing a little picture. All right, let's try to do this. Well, what do we have here? This is supposed to be a tree, and where on the tree are usually your roots? On the bottom. I hope that helps. All right, so let's go ahead and simplify some things. 27 raised to the 2/3 power. So what I will do, I will rewrite this. There is a 3 in the denominator right here, and that will turn into a cubic root of 27. And there is a 2 in the numerator, and that will turn this into an exponent. Now, where I put the exponent doesn't really matter. If I would put it in here, that would make my life a little bit more difficult, but I'm going to put it on the outside. And why did I put this on the outside? Because now I see that the cubic root out of 27, oh my goodness, that was actually something nice. That was something easy. I know what the cubic root out of 27 is, and that is 3. 3 raised to the 3rd power is 27. 27 is a cubic number. Now I just have to look at the 2 as an exponent on the outside, and 3 raised to the 2nd power, that will give me 9. So in other words, 27 raised to the 2/3 is nothing else but your number 9. Let's rewrite some things. The 7th root out of x raised to the 4th power. We have technically done an example like this already before, but let's do it again. This means nothing else but this. This is x to the 4th and raise this to the 1/7. And if I multiply now the 4 and the 1/7, I get x raised to the 4/7. And look what I could have done as well. A moment. There you go. We said that this 7 right here goes in the bottom of your exponent. And you see that this is exactly what happened right here. 4/7 is what we will end up with. But you need to know how you got there. So I'm going to do the same thing with this one here on the right-hand side. Now, what do we have? We have the square root of 11xy, raise it to the 5th power. So if I want to rewrite this, then what I will have to do, I look on the inside of the parentheses, and that will give me now 11x times y. This was the square root. So this 2 right here goes underneath the 5. The 5 stays on the top, and I get 5/2. The long way to see why this works this way is the following. I will first look at this on the inside. This will give me 11xy raised to the 1/2, and then I still had raise it to the 5th power on the outside. So I first just rewrote the radical, and now I have to multiply the two exponents, and I will get 11xy raised to the 5/2, which is exactly what we got right here. All right, so now we are going to look at how to simplify expressions with rational exponents. And yes, it's the return of the rules for exponents. All of the rules are exactly the same. The rules never change. The rules all stay exactly the same. These are the rules that we have already seen for exponents. Let's make them pink so that they are staying out for us. All of those rules we are using now, but remember, the exponents now will be fractions for us. So the moral of the story is you need to know how to add, subtract, multiply, and divide fractions. If you need a reminder on this, go back and look it up. You need to know how to do these. Adding and subtraction, you need to have a same denominator. If you don't have it yet in the beginning, then you need to manipulate them. Multiplication is simple. You just multiply straight across. For instance, 2/3 multiplied with 5/8. You just multiply this, strictly speaking, straight across. 2 times 5 divided by 3 times 8. And then you simplify. Really quickly, what did I do with division? What did I have there? 5/8. Division, you multiply with the reciprocal, with 5/8. And then you do the same thing as before. 2 times 5 divided by 3 times 8. All right, that was a really quick reminder. So if I want to simplify now, x raised to the 3/7 divided by x raised to the 1/7. What did my rule say? Top minus bottom. Top minus bottom. The top exponent was 3/7. The bottom exponent is 1/7. Now this is really nice because the denominators in both cases are the same. So I will get 3 minus 1/7, which is just 2/7. See, the only thing that was difficult here is how to subtract the denominators. All right, getting crazier. We have to do several steps here. What was the rule that we had when we had an exponent on the outside of something that was multiplied? That right here jumps to both. Let me write it down in detail so that you see exactly what is happening. x raised to the 1/4, raise that to the 1/3, times y raised to the negative 2/5, raise that one as well to the 1/3. So both factors are being raised to the 1/3. Now my rule said for this that I had to multiply the exponents. I have a negative 2/5 and I multiply it with 1/3. And what I get when I multiply these fractions out, I get 1/4 times 1/3 is 1/12. Y raised to the negative 2/5 times 1/3, that is a negative 2/15. Remember, when we have negative exponents will be turned into positive exponents by simply changing their position. It drops into the denominator. And I am done. Let's do one that looks really crazy. 5 raised to the 3/4 times 5 raised to the 1/2, and I believe that this should be our last example. Now there will be one more example after this. So let's just do it, one step after another. I look at the top first. So what rule do I have at the top? We are supposed to add the exponents. So what in the world is 3/4 plus 1/2? Well, they do not have the same denominator, but the least common denominator is 4. So I take 1/2 and I multiply the top and the bottom by 2 to get 2/4. And now plus 3/4 plus 2/4, well, that is going to be 5/4. So in short, 3/4 plus 1/2 is 5/4. This is supposed to be a 4. All right, last step. Top minus bottom. 5/4 minus 1/4. Let's have a look. What is 5/4 minus 1/4? That is 5 minus 1, which is 4/4. Well, and 4/4 is nothing else but 1, and 5 raised to the 1 is just 5. So this is kind of like a mathematical joke that this whole thing turns out to be exactly equal to 5 after doing all of our simplifications. Last example for today. 50x to the 1/3 divided by 10x to the 4/3. So we are splitting this into two problems. This is 50 over 10 times x to the 1/3 divided by x to the 4/3 will be x to the 1/3 minus 4/3, top minus bottom. Now 50 divided by 10, that is just 5. 1/3 minus 4/3, that will be a negative 3/3, which is a negative 1. And x raised to the negative 1, we never leave negative exponents, will just move this x into the denominator, x to the positive 1. I do not need to write the 1. This is my final answer.